Welcome to this performance comparison between NumPy arrays and Python lists. In this video, we'll explore why NumPy is the go-to choice for numerical computing and data science. We'll examine the fundamental differences between these two data structures and demonstrate just how much faster NumPy can be for mathematical operations. Let's start with Python lists. Python lists are dynamic arrays that can store mixed data types. This means you can have integers, strings, floats, and booleans all in the same list. For example, you can create a simple list with numbers 1 through 5, or a mixed list containing an integer, a string, a float, and a boolean value. This flexibility makes Python lists very versatile for general programming tasks. Now let's look at NumPy arrays. NumPy arrays are homogeneous arrays, meaning they store only one data type. They're specifically optimized for numerical operations. To create a NumPy array, you first import the NumPy library, typically using the alias np. Then you can use the array function to create an array from a list. While this might seem limiting compared to Python lists, this constraint is actually what enables NumPy's incredible performance. Here are the key differences between these two structures. Python lists can handle mixed data types, have dynamic sizing that allows them to grow or shrink, and store object references in memory. NumPy arrays, on the other hand, require a single data type, have fixed sizing once created, and store data in contiguous memory blocks. These differences might seem minor, but they have massive implications for performance. The memory storage model is crucial to understanding the performance difference. Python lists use scattered memory, where each element is actually a pointer to an object stored elsewhere in memory. This creates significant memory overhead. NumPy arrays use contiguous memory, storing data directly in sequential memory locations. This makes NumPy arrays much more cache efficient, allowing the processor to access and process data much faster. Let's set up a performance test to see the difference in action. We'll import NumPy and the time module. Then we'll create a large dataset with 1 million elements. We create a Python list using the range function and then convert it to a NumPy array. With this setup, we can now compare how long it takes each structure to perform the same mathematical operations. Here are the results of our performance test. For a simple mathematical operation on 1 million elements, the Python list takes 250 milliseconds to complete. The NumPy array completes the same operation in just 2 milliseconds. That means NumPy is 125 times faster than Python lists for this operation. This speed difference becomes even more dramatic as datasets grow larger. So why is NumPy so much faster? There are 4 main reasons. First, contiguous memory layout allows for efficient data access. Second, vectorized operations are implemented in C, avoiding Python's interpretation overhead. Third, fixed data types eliminate the need for type checking during operations. And fourth, optimized CPU cache usage means the processor can work with data more efficiently. Together, these factors make NumPy the superior choice for numerical computing and data analysis.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.